Hello and welcome to another video where I will be building this here quadrupedal robot. In a past video I completed a smaller bot, but to be honest it didn't work very well. It ended up being underpowered, slow, not self-contained, and hard to program changes to the walking sequence. This new one should hopefully fix all those issues, while also adding some new features. And it's also bigger. Anyway, let's start with the mechanical assembly. So the basics for this robot is 4 legs with 3 degrees of freedom per leg, a thigh joint, a knee, and an ankle. This allows the foot to position itself in 2 axes as well as change the foot's surface area on the ground with the ankle joint. Ideally, there would be another joint so the leg could position itself in 3 axes, but 2 will work. I'm using an MG99R servo motors for the thigh and knee and a smaller micro servo motor for the ankle. The bulk of the legs are 3D printed and attached to the motors via the servo horns that come with them. After assembling 4 of the legs, I attached them to a small plywood board spray painted white. With the mechanical assembly completed, it's time for the electronics. Okay, so I was going to make a circuit schematic, but that didn't end up working, so instead I'm just going to show you. So, the brains of it are the Arduino Mega right under all these wires. Then, it's all powered with a 12-volt, 2-amp-hour rechargeable drill battery. That drill battery is connected to this 12 to 6-volt regulator, and that is because the servos are powered with 6 volts, but the drill battery is 12 volts. Then, the regulator goes to these 2 bolts, which are attached to a 3D printed part. Then attached those are wires. One is for ground on this side and then power on this side, and each of those wires goes to the wires on the servo motors, ground and power. Then the other wire on the servo motors, the signal wire, go to the digital pins on the Arduino. Now, other than that, there are 2 extra features that I added. One is a relay right here, and that connects to the Arduino power. So if I plug the Arduino in and power the Arduino, it'll automatically switch and connect the 12-volt battery to the servo motor, so I don't have to do that manually. The other thing is this MPU 6050 gyroscope and accelerometer right there, and that's purpose will become more clear once we look at the code. So, one of the problems I mentioned before was that it's really hard to make good and alterable walking sequences by just guess and checking servo positions. The solution to that is the horrifying world of kinematics. My kinematic model makes it possible to import coordinates, like 4, 7 or something. And then the Arduino will work out all the angles so that the arm, the end of it, will be on top of that position. So, how do I do that? I'm not going to go into all the math, but I'll give you the general process. So the first thing is you take the coordinate and you turn it into a triangle. It's kind of hard. Now, we want 2 things from this. I need the angle here and the length of this line. Once we have the angle and the length of the line, then we can draw another triangle where this length is equal to this length. Then we take this angle and add it to this angle, so it ends up with something like that hovers over the top. That, however, is not all I have to do. There is one more thing, and that is because I have a foot. And now the idea of the foot is that it can be parallel to the ground when I want it to be. So I have to work out the math. So I can find the angle here that makes it so this is parallel with the ground. I do that by subdividing into a bunch of smaller triangles and then finding transversals. I'm not going to get into that in this one. And the last thing is a disclaimer. I don't actually know how to do kinematics. I just kind of made this up on myself because I don't understand the real equation, so this could be how you're actually supposed to do it, or it could not. But either way, it works, so I'm using it. And now it's time for the code. This was probably the most time-consuming part of the entire thing. So here is the first page. So it at the start, you see it includes libraries and then has stuff for the accelerometer. After that, it initializes servos. Page 2 is more setup necessary for the relay, accelerometer, and gyroscope, and servo motors. Page 3 includes a lot of the move to functions that I built and you'll see later, and this contains the entire walking sequence. It is much more alterable than the last version. This is the start of the move to function, which takes parameters such as the X and Y axis numbers, and which leg you want to move. And here is where the bulk of the math I outlined earlier is contained. This is where it turns the coordinates on a grid into angles for the legs to move to. This bit of code is not strictly necessary, but it's also helpful for debugging. It stops the robot from doing things that are impossible. And finally, here is where we take those values from above and actually tell the servo motors to move to them. And this is why I have the gyroscope and accelerometer on board. If the fourth parameter in the move to function equals 1, then it'll activate this piece of code. What this does is it automatically detects the tilt of the robot and adjusts the feet so that even if the robot is tilted, the feet are still flat on the ground. Although this worked in the air for me, on the ground it hasn't worked yet because I am getting unusual spikes and that will make the feet do crazy things that it's not supposed to. So in a future video, I'll probably try and smooth that out and see if I can get it working. This is the same piece of code, except it's just for the second and fourth leg. Still more code for moving the feet. And finally, the last piece of code. So this is just for ease of use, and this basically outputs to the serial monitor every single piece of information I need to know. So after all that, it's time for it to walk.